Hi, I'm Mark Duchesneau, and I'd like to reflect on the roaming terrain paper as it turns 25 years old. But first I would like to acknowledge the amazing team that put it together with me. Murray Walensky, David Seghetti, Mark Miller, Chuck Aldrich, and Mark Monet of Weinstein. What were the main ideas? The first was the binary tree of triangles, a simple view of what eventually were called 4-8 meshes, where triangles are split and merged to add or remove detail in an optimal order. Another big idea was doing work incrementally, taking time proportionate to the number of triangles changed from one frame to the next. A subtle but important concept was also introduced, allowing a wide variety of factors in a dynamic objective function, from the basics of view dependence to things like line of sight or contact with moving objects. Some optimizations about triangle stripping became obsolete within a couple of years, but most of the ideas lived on. My co-authors and I were delighted to see how these ideas spread and were extended and adapted in so many ways. What motivated this work, as is often the case, was a great problem from a real application. For us, the challenge was to help make a holodeck, but for aircraft, not humans. How can you stimulate the sensors on a plane so that it thinks it is flying in the real world? At the time, the only graphics hardware with enough capability cost millions of dollars. But that changed quickly. Within a few years, the industry was disrupted with $200 graphics cards with similar performance. Performance started doubling every couple of years, so some algorithm updates were needed. Several results came out to address the need to compute more triangles using less CPU work. All involved using patches of pre-optimized triangle meshes to replace the individual triangles within a Rome optimizer. I'll point out 3 results in this area by Alex Pomerantz, Thatcher Ulrich, Joshua Levenberg, respectively. Their algorithms reduced CPU work by orders of magnitude while closely approximating the optimality of working one triangle at a time. The Rome ideas were adapted and extended in creative ways by the game development community. I would especially like to call out the award-winning work of the late Seamus McNally, who helped the game community understand and adopt binary triangle trees and dynamic terrain, sparking wider interest in Rome. Rome has been generalized in numerous ways. I'll mention 4 highlights. Ben Grigorsky led work using Rome concepts on tetrahedral meshes. Lo Qua led an effort to extend Rome to texturing, I/O, and image filtering computations. Paolo Cignoni led work moving to unstructured meshes. And we also did work to add arbitrary surface topologies and wavelet compression. The ideas of Rome are not written in stone, unchanging. The mesh structures, incremental optimization, and dynamic objective functions can and should morph into new areas. Some possibilities I've been thinking about include adding incremental visibility computations, view-dependent computation of physics like fluid flow, or even doing 3D reconstruction interactively in a view-dependent way. Thanks for honoring the Rome work. It has been quite a journey helping the community that sprung up around it.